This video is on solving absolute value inequalities. An absolute value inequality is an inequality that contains absolute value. Recall the following. Inequalities do not have just one solution. Their solutions are a range of values, and any number that meets the condition or conditions is a possible solution. So for example, the inequality x is less than 2, x can be any number that is less than 2. That's not just one number. X is greater than or equal to negative 4. X can be negative 4 or any number that is larger than that. Negative 3 is less than x, which is less than 6. X can be any number that's between negative 3 and 6, but not including negative 3 and 6. And x is less than or equal to negative 2, or x is greater than or equal to 5. So x can be any number that is less than or equal to negative 2, or any number that is greater than or equal to 5. Recall also that absolute value refers to distance. For example, the absolute value of x equals 4 means what values of x, are 4 units from 0 on a number line. And a graph of this would look like this. So these two solutions, x equals negative 4 and x equals 4, are the two numbers that are 4 units from 0 on a number line. Because from negative 4 to 0 is 4 units, from 4 to 0 is 4 units. Therefore, the absolute value of x is less than 5 means what numbers are less than 5 units from 0 on a number line. A graph of it would look like this. So between on this blue line right here are all of the numbers that are less than 5 units from 0 on a number line. Notice that this graph is the graph of a compound inequality. X is greater than negative 5, so that would be from negative 5 here going in the positive direction, and x is less than 5, starting at 5 and going in the negative direction, which could also be written as negative 5 is less than x, which is less than 5. In other words, x is between negative 5 and 5. A less than absolute value inequality is an and compound inequality. The solutions are any numbers that are greater than negative 5 and are less than a positive 5. Similarly, the absolute value of x is greater than or equal to 5 means what numbers are greater than or equal to 5 units from 0 on a number line. A graph of it looks like this. So we start at negative 5 and then we're going in the negative direction, and we're starting at positive 5 and going off in the positive direction. Any of those numbers are at least, that is, equal to or greater than 5 units from 0 on the number line. Notice that this is a graph of a compound inequality. X is less than negative 5 or x is greater than 5. A greater than absolute value inequality turns into an or inequality. Its solutions are any numbers that are less than or equal to negative 5 or are greater than or equal to 5. To solve an absolute value inequality, we're going to rewrite it as a compound inequality. If the absolute value of an expression is less than a given value, then the expression is between the positive and the negative of that given value. This becomes an and inequality. If the absolute value of an expression is greater than a given value, then the expression is greater than the positive of the given value and less than the negative of the given value. This becomes an or inequality. Let's take a look at a couple examples here. So we need to solve each absolute value inequality and then graph the solution. So here we have the absolute value of 4x plus 3 is less than 5. So in other words, what are the values of x that make this expression less than 5 units from our central number? So since this is going to be a less than, this is going to turn into an and inequality. And I prefer to write my and inequalities like this. So negative 5 is less than 4x plus 3, which is less than 5. You could also write this as two inequalities. You could write it as 4x plus 3 is greater than negative 5 and 4x plus 3 is less than a positive 5, but I think it's simpler to do it this way. So solving this compound inequality, I want to get x all by itself in the middle. So the first thing I'm going to do is subtract 3 from each part. So negative 8 is less than 4x, which is less than 2. And dividing each part by 4, I get that negative 2 is less than x, which is less than 1/2. Graphing that on a number line, actually all I really have to put on there are those two numbers. And since x is between those two values, and it's a less than, not a less than or equal to, I have open circles, and there's my graph. And my last example here is the absolute value of 2x plus 6 is greater than or equal to 10. Since this is a greater than, it's going to turn into an or absolute value, or an or compound inequality. Now remember, you can't write or as like one expression the way I did in number 1. I have to actually write it as two expressions. So 2x plus 6 is going to be greater than or equal to a positive 10, or 2x plus 6 is less than or equal to a negative 10. And now we're just going to solve each one of those. So 2x is greater than or equal to 4, and dividing by 2, x is greater than or equal to 2, or, and we'll solve this one, 2x is less than or equal to negative 16, and dividing by 2, x is less than or equal to negative 8. So there's my solution. Make sure that you put the word or in there. And then to graph that, I will do a number line with those two numbers, negative 8 and 2. And so x is greater than or equal to 2, or x is less than or equal to negative 8. So in this video, we took a look at how to solve an absolute value inequality by rewriting it as a compound inequality.